Okay, so here we go, example 4 on chapter 7.2. As usual, let's start just by reading the question and lifting out the key facts that we're going to need. A mass of 3 kilograms rests on a surface of a smooth plane which is inclined at an angle of 45 degrees to the horizontal. The mass is attached to a cable which passes up the plane along the line of greatest slope and passes over a smooth pulley at the top of the plane. The cable carries a mass of 1 kilogram freely suspended at the other end. The masses are modelled as particles. The cable is light and inextensible. There is a force of P newtons acting horizontally on the 3 kilogram mass and the system is in equilibrium. We're asked to find and calculate the magnitude of P, the normal reaction between the mass and the plane, and state how you have used the assumption that the pulley is smooth in your calculations. So, first thing to do with any of this is to add the necessary forces to the diagram. So, let's have a look at what we've got acting here. We've got a weight of 1 kilogram acting downwards, 1 newton acting... hang on, what's happened there? Rub that out, he says optimistically. Let's try again. Okay, so it's mass of 1 kilogram, so we've got G newtons acting downwards. We've got a tension in the cable, we'll call it T. And we know that because the string is light and inextensible, that tension is constant throughout the string and the pulley is smooth. On the 3 kilogram weight, we've got the tension, as we've already written in. We've got its weight acting downwards, which is 3G, and we will have a normal reaction to the plane R. Let's call this particle A, and this one B, so we can refer to them later on in the question. Okay, let's go back and see what we've got to do. The magnitude of P. So if we're going to work on the magnitude of P, let's look at particle P. And when we work on P, we've got a plane, so we're going to choose to work parallel to the plane and perpendicular to the plane. And in order to do that, we've got to break some forces down into their components. Which two forces is it, do you think, that need breaking down into their components? Hopefully you've picked out the right ones. Yeah, Stefan, which ones did you pick? Hopefully P and 3G. So we're going to just work on those. So parallel to the plane, P, we've got P, and this angle in here is 45 because it's alternate. So we've got P cos 45 because that one is adjacent to the angle. Also in that direction we've got a component due to the weight. Oops, undo. We've got a component due to the weight, which will be 3G, and this is opposite the angle, so that's going to be sine of 45. Perpendicular to the plane, we've got here, that angle in there we've already said is 45, so this will be 3G sine of 45, and here we're opposite the angle again, so this is P sine of 45 degrees. Okay, so hopefully now we can use that to help us with the question. So part A, we are going to resolve parallel to the plane and up the plane, and we get T. Let's look on here and just see which other bits we've got. So in that direction we've got 3g sine 45, p cos 45 and t as our three forces in that direction. So we've got t plus p cos of 45 minus 3g sine of 45 equals to 0, since equilibrium. Okay, now there we've got one equation with two unknowns, so we're going to need another equation. Well, we've seen this kind of thing before with connected particles problems, so we're also going to look at particle A. So that was first of all resolve on B, parallel up the plane. We're now going to resolve on A. Which direction do you think that's going to be in? Yeah, have you got that, Jermaine? Yeah, that's going to have to be down. So we keep our positives constant throughout the context. So we're going up and round. So it's up the plane on B and down when we're looking at A. So we get G minus T, it's in equilibrium, so that's equal to 0. So since equilibrium. Now we've been asked to find P, so T equals G, and then we can substitute straight in for T up here. So these substitute in here, and we're going to get G plus P cos of 45 minus 3G sine of 45 is equal to 0. Now we've just got to work that out then. So P cos of 45 equals 3G sine of 45 minus G. Cos and sine of 45 we should know to be root 2 over 2. So we get root 2 over 2p equals root 3 root 2 over 2 g minus g. Multiply through by 2, so we get root 2p equals 3 root 2g minus 2g. Divide by root 2, so we get 3g minus 2 over root 2g. And if we multiply that last bit by root 2 over root 2, we get P. Whoops. We get P equals 3g minus the root 2 times the root 2 in the denominator will make 2, which will cancel with the 2 on the top to leave us root 2g. Factorise 3 minus root 2 lots of g. Root 2 is roughly 1.4, so 3 minus 1.4 is 1.6 times g, which is roughly 10. It's going to be roughly 16. But you can tap it in the calculator, and indeed it is 16 to 2SF. So 16 newtons to 2 sig fix. Okay, let's go back, read the question, check we've answered it. So yes, we've got the magnitude of P. Part B says the normal reaction between the mass and the plane. So for part B, we need to resolve perpendicular to our plane. So if we're going to do that, the forces that we're going to want on our diagram perpendicular to the plane on B is going to be there and there. So we've got R minus 3g sine of 45. Okay. So, what did we say? R minus 3g 45. R minus 3g sine of 45 equals 0 since equilibrium. Is that everything? That doesn't sound quite right to me. Can you see a mistake there? Hopefully you have spotted it, because there's another force with a perpendicular component, isn't there? P sine 45. So let's tidy this up. We've also got R minus 3g sine 45 minus P sine of 45 equals 0 since equilibrium. So R is equal to 3g sine of 45 plus P sine of 45. So 3g times root 2 over 2 plus P was 3g minus root 2g times root 2 over 2. So we've now got two lots. So we've got 3g root 2 over 2 plus, expanding this, 3g root 2 over 2, so they're the same, minus root 2 right times root 2, which is 2, all over 2, so it's minus g. So if we tidy that up, we've got 3g root 2 plus 3g root 2, both over 2, which will be 6g root 2 over 2, which becomes 3g root 2 minus g. So 3 root 2 minus 1 lots of g, which is approximately 3 lots of 1.4, which is 4.2, 3.2 g, so roughly 32 newtons. Tap it in the calculator to check. Yep, it is 32 newtons to 2s F. Good. Okay, let's move back to the question and check again. Part C, we've got there. State how you have used the assumption that the pulley is smooth in your calculations. So we've already really said it earlier on. The pulley is smooth, or as the pulley is smooth, the tension is the same on either, or perhaps it's better to say both, on both sides of the pulley. Okay, so the work attached with that is exercise 7b. Questions 5, 6, 7, 11, 12. 5, 6, 7, 11 and 12 should do you. That's on page 135 stroke or 2137. Good luck with that, and let me know please on Frog how you've got on. Cheers.